let's dig a bit deeper into the visual and logical trees. We've already spoken about what a logical tree is, and a logical tree is just a XAML. It can even be the C# code behind. It's just the coded version of your UI. And the visual is the actual UI itself. So that's really the separation between visual and logic. If it isn't the actual layout itself, visually being rendered to screen, then it is the logical side. In Avalonia, typically the logical tree is XAML. It's the way you should do it. It just works, and it's the best way for making UI. We can zoom in here a little. Oh, that's a bit too much. Zoom in here like this. Can we collapse this sidebar? I don't think we can. It's maybe something we should add to the website, so we can collapse that side menu when we're zoomed in. So this has got exactly what we have here, just with all of the attributes cleaned up. But obviously that would error in real code. So it's just a nice clean way of visualizing what's happening. And this is pretty much how our application looks. We have a window, then an indent, then a stack panel. The stack panel then contains the text block, text box, and button. That then gives us this nice visual, and I just like to think of that as a file system. So most people on computers know about Windows folders or Mac folders, but on Mac, it's not the best way to see this. So see in Mac, it kind of lays itself out like this and then like this. So this is a way to represent it in Mac. Just change to the icon list option, and then you'll see the folders, and you can expand, and you can think of, say, this is the window, this is the stack panel, this is the elements inside. That's the visual we're trying to get in our head. And that's just useful because for some of us, it just comes naturally. Like we might just make this XAML up, and I'm already thinking, well, obviously this label is inside the stack panel, and then this stack panel is nested inside of this one. But if you're learning to code, that might not be obvious to you. That might be something that this diagram and this idea and concept helps you out to really understand the concept. So it's one of those things that's sometimes hard to teach if it's already natural to you because you wouldn't think of it. So I think these are really nice ways to help you understand that. So static resources and dynamic resources, the way they are coded naturally can resolve and navigate their way up this kind of dependency. So if we added a style in the text box, or even if we didn't, the text box would inherit a style from potentially the window or the stack panel and walk down the tree, and other things can walk up the tree. Data context is data binding. So again, in this window, for example, we have bound by doing this, and by actually doing this in the designer, we've bound the Windows data context to this main window view model, which is just a class which has greeting in. But then as you've seen, even though the window has it, if we come all the way down to say this label, and we bound down here to greeting, and we look over here now, it says welcome to Avalonia. So what has happened here is the nested label has gained the binding of the Windows data context. And that is this data context inheritance. That, in a nutshell, is what it's on about. And it propagates down the logical tree. So that's what it's saying. It's coming from the window that has this data context, and it's walked down this logical tree into our label here. So that's what's happened there. And this is why it's good, again, to kind of understand what we're talking about when we're saying we're walking up and down the tree. We're talking about going up and down these indents in XAML. And again, I touched on this, the font size and foreground flow down the logical tree just the same. So the reason this label, for example, has black text is because it will have walked down the tree from the window that has styles down into the stack panel, down into the label. So styles inherit down. All the styles come from themes that we'll touch on again in another video. Name, we've seen this used, but this is where it helps us to resolve things outside of XAML back into the code behind. So that would be if we were to, I think we might even have it in here. We've already done name. There's no need anymore for this x:\name, by the way. This is just what WPF did, but now name resolves exactly the same. So the documentation telling us this is technically legacy. You can just do name. And by doing this name, this then resolves to the code behind in here, as we saw when we were messing with it here to do different things. It helps us to get, for example, status text. And the status text, if you look for it, will be the text block having a name. So this propagates from the XAML into the code behind through the Avalonia source generators. That's how that's all working. Now, here's just a quick useful example if we wanted to walk the tree up and down what we can see. And you start by getting a control and its parent. So let's take our actual example here where we click a button. We've already got stuff here where we're getting top level. What we could do is just say var parent equals, and the sender will be a button in this case, so we can do button sender dot parent. Now, if we just put a breakpoint here and run the code, we can just observe what the parent is. Now, the parent, before we breakpoint there, which is going to hit now, we should expect, you can see this button here is what we're going to click on. The parent, if we scroll up, it's not going to be the stack panel because it's in line with it. This is a sibling. If we keep scrolling up and look for the next indent, here it is. So it should be the top level stack panel. And then if we were to walk up the stack panel's parent, it should go up and become the window. So let's take a look if that's true. If we click the button, we get to here. We can hover over now to see the parent, and you can see it's a stack panel as we expected. Now, is the stack panel's parent the window? So scroll down in here, and this is a great way to see. And there you go, main window. And then say we wanted to walk back down the tree, we can scroll down and we can see the window has content, which is stack panel. Inside the stack panel, it has children. So we can expand into that and look at the raw view. And inside that children, instead if we go into results, this is a bit easier to see. You can see the stack panel has a label, another two stack panels, a button and a text box. So we looked at that in here. You can see this stack panel has a label, a stack panel, a button and a text box. So that's exactly what we saw. We've just done it through the debugger, whereas this is a code way of doing the same thing. You can basically get the parent or the children. You can loop over the children in the loop, or you can even use the control like a button and click find logical ancestor of type to search for ancestors above that are a type of window. It's just all logic to go up and down that tree. Here is just a warning if you are ever going to edit the logical tree, which would edit the UI as well, that you can only safely edit a list of UI elements, for example, when it's safe to do so. Same kind of thing as thread safety and UI locking and anything that you're doing in lists with databases. You don't want to mutate a list while you're inside of it, basically, is the warning there. And this is how to avoid it and do it properly. It's not something you'll ever usually do, is code behind inside of lists. If you're doing MVVM, this wouldn't ever really crop up. Now you can see here the visual tree has actually been referenced a little bit cleaner than what I've mentioned. So one thing I said before was in this window, I mentioned, oh, you can just ignore this Design.DataContext. But this is technically in the logical tree. You can see it, it's here, it exists. What we are getting at is this doesn't end up being rendered into the UI. So this is excluded from the visual tree. And then you could still represent the visual tree as we're doing here, as a kind of tree view or folder view. And you can imagine if this was the window, and then this was our stack panel here, what we've done is purposely excluded the Design.DataContext from this level. So the visual tree is the tree of every element that gets rendered, and things that exist in XAML, like this Design.DataContext, get excluded from that list, whereas this really could be in the logical tree, for example. And we've seen above how to navigate the logical tree by just getting parent and children. But you can also navigate this visual tree. You can do stuff like GetVisualParent and just use that instead of parent. So again, very similar, but specific to the visual side of things. And then here's a nice breakdown of the key differences. So you can see a nice lookup table here if you want to compare. There's then further information again if you want to dig deeper and really investigate and look at the trees being built. The best way, like I say, is just to breakpoint on one of the positions, hover over, and now just inspect the element and browse through it yourself and expand and see what's happening. So you can see there's an inheritance parent there that goes into the ContentPresenter, which has templates inside of them. So you could break into that. And this is the way I do a lot of things when I'm investigating code and I'm not sure. I put a breakpoint, hover over, and just do a live inspect. That is often more useful than anything else. These parts here touching on templated parts in the visual tree and overlay layers and adding custom overlays, all this is really beyond what we've touched so far. So this isn't going to be of any use explaining to you right now because it's well beyond where we've gotten to. So you can always step back to this once this actually makes sense to you. This is not really in the correct position of learning right now for what we want to do. but it's there if you need to see it.